Good morning, students. Today, let us see Unit 1 Introduction to Compilers. The various topics in our unit is structure of a compiler, lexical analysis, role of the lexical analyzer, input buffering, specification of tokens, recognition of tokens, lex tool, finite automata, regular expressions to automata, and minimized DFA. Now, structure of a compiler. Now, a compiler is a program that takes a program written in a source language and translates it into an equivalent program in a target language. So, this is a basic block diagram. Now, what does a compiler do? It translates from a source language, typically a high level language, to a functionally equivalent target language, typically the machine code of a particular machine or a machine independent virtual machine. Right? Now, what are the various applications? It can be used in program analysis, it can be used in extending an existing programming language, it can be used in processing XML and NLP. Okay, the various other applications are it can be even be applicable to solve many problems in computer science. Now, let us see the structure of the compiler. Two major parts of the compiler are analysis and synthesis. In the analysis phase, an intermediate representation is created. In the synthesis phase, the equivalent target code is created from this intermediate representation. Now, this is the phases of compiler. The input is the source code, the output is the target code. The two important parts which is required for each and every phase of compiler are the symbol table and the error handler. The first phase is lexical analyzer, otherwise called as scanner. The second phase is syntax analyzer, otherwise called as parser. The third phase is semantic analyzer. Fourth is intermediate code generation. Then we have machine independent code optimizer, code generator, and machine dependent code optimizer. So we have source program, LA, SA, semantic analyzer, ICG, CO, CG, and the target program. Each phase transforms the source program from one representation into another representation. They communicate with error handlers. They communicate with the symbol table. Okay, let us see an example. Okay, position is equal to initial plus rate into 60. Now, the lexical analyzer, it separates each and every part in that line, whether it is a variable or a special character or assignment operator, relational operator, or variable or constant. Right? Now, syntax analyzer, it will check for syntax of the expression. Right? We'll be constructing the syntax tree, and using the context-free grammar, we'll be constructing the parse tree. Next is a semantic analyzer where type checking and type conversion will be done. The implicit type conversion, you call it as coefficients, right? If all the variables are of different data type, we are converting it into similar data type, right? Now, next is your intermediate code generation. In the intermediate code generation, we are using various temporaries and we'll be having the three address code. That is two operands with one operator and the resultant operand. Code optimizer. Our main important concept here is optimization, minimizing the size of the code. So we try to optimize the code in such a way that the time consumption is less and the number of code is also less. The last is but not least is the code generator. It produces a target language in a specific architecture. So finally we get the assembly code. Thank you, students.